Rise and shine, porcupines. Guess what? It's Algebra with Al time, and I'm your host, Al Rosetti. Today we're looking at Chapter 5, Unit 1, Operations with Polynomials. So after watching this video, students will be able to simplify polynomials through addition, subtraction, multiplication, and division. So the concept is polynomials. The skill is being able to add, subtract, multiply, and divide. Okay, so what do you say we get started? Here we go. All right, looking at number 1. We have b to the 4th times b to the 3rd. Now, let's take a look at this because if we go through this one, then the other ones will be very quick to do. So remember, b to the 4th means you have 4 b's, right? b to the 3rd means you have 3. When you're multiplying, unlike adding and subtracting, you can multiply any variables you want. It's not like addition and subtraction where they have to be like terms. So what do we have when we're done? We have b to the 7th. Now we're only going to write the letter b one time. We could write b 7 times. That would be the same answer. But who does that? We're going to count how many b's we have. We're going to count for every one of them, but we're going to count for them in terms of an exponent. So if I have 7 b's, I'm not going to write b out 7 times, but I am going to write b to the 7th. Okay? That's how we would do it. So look at the next one. C to the 5th, c squared, c squared. Well, I'm going to write c one time, and I'm going to count for every one of those c's. There's a total of 9. So instead of writing it 9 times, I'm going to write it one time, and I'm going to write the exponent 9. So c to the 9th, right? Think of it as a type of shorthand, if you will, right? Instead of writing it out 9 times, you can write it c to the 9th. All right, so number 4. Now if we just stick to what we've been doing, right? We have 5 x's times a negative 4, right? The exponent's negative 4, and then remember that last one is x to the 1st. So we have 5 minus 4 plus 1 is x to the 5th. So we're gonna keep in that same frame, right? We got 5 x's. Then they want us to take away 4 x's. That's what that minus 4 is. Then they're gonna give us 1 more. So 5 minus 4 plus 1, x squared. All right, number 5. So what we have to do is remember that 2x in parentheses to the 2nd power means 2x times 2x. Same with the 4y to the 2nd power, that means 4y times 4y. And if you look at it like that, well, it's basically the same things we just did, right? If we write out 2x and 2x, and then 4y and 4y, what do we have? Well, we have 2 times 2 is 4, right? And we have 2 x's. We're only going to write it one time. We're going to write the exponent as 2. So we have 4x squared. Now, 4y and 4y, what do you have? You have 4 times 4 is 16. You have 2 y's, so you have y squared. Now, like I said, this is not like addition and subtraction. This is multiplication now. And we can multiply any terms we want. If we were adding these and subtracting, we could not combine these terms because they're not like terms. But that does not follow suit for multiplication. All we're going to do is multiply 4 times 16, which is 64. And how many x's do we have? We have 2, x squared. How many y's do we have? We have 2, y squared. So in the end, this whole thing becomes 64, x squared, y squared. So remember, multiplication, we can multiply any terms we want. They do not have to be like terms, right? So, and then we just count how many x's or y's we have, and we're going to write the number as an exponent. Okay, look at number 6. So negative 2, right, gh, then inside the parentheses, g to the 3rd power and h to the 5th. Now there's no other value for negative 2 to be multiplied by because we're only going to multiply it with another constant. So we know negative 2 is our answer. Now count how many g's you have. 1 g after the 2, and then 3 more in the parentheses is g to the 4th. Look at how many h's you have. You have 1 with the 2 and 5 more in the parentheses. So we're not gonna write it out h, we're gonna write h to the 6th. Although if you wrote it out 6 times, it would be the correct answer, but we're not gonna do that, right? That's just too much. All right, let's look at number 7. So 10x squared y cubed, in parentheses, 10xy to the 0 power. So let's just start with the numbers. Let's start with those coefficients, right? Because it's always multiplying numbers with numbers. So 10 times 10, okay? Separate, we got 100. We're done with that. Now, how many x's do we have? We have 2 with the first 10 and another 1 in the parentheses. So that's just 3, right? So it would be 100, x to the 3rd, and then how many y's do I have? I have 3 and 8, y to the 11th. Like I said, if you wanted to, you could write out y 11 times, but like I said, that's just doing too much. All right, number 8. Now we're talking about division here, okay? You got the fraction bar, division. Now what we were doing when we were multiplying is we were counting up how many we had. Here, think about it. If we were adding them for multiplication, what do you think we're doing for division, since division is the opposite of multiplication? What's the opposite of addition, right? Subtraction. So what we're gonna do, we're gonna take 24 over 3, we're gonna simplify that individually by itself. We're gonna separate it. We have 1 W on top, 3 on the bottom. We're gonna divide out 1 W from top and bottom. We're left with 2. In the denominator, we have to leave it in the denominator. So that is 8 over W squared. Now the Z's, the 2 remaining are up top, so it stays in the numerator. So there's your answer, 8Z squared over W squared, okay? Key, if it's in the denominator and it's bigger than the numerator, it stays in the denominator. Once a fraction, always a fraction. All right, so let's take a look at number 9, same thing. You have negative 6 over 36, right? So we are going to separate those coefficients and handle them as if the variables are not even there. All right, we're gonna go negative 6 over 36, as we know is 1 over 6. Now, you can write the 1 right now if you want, but if there ends up being something in the numerator, we wouldn't write the number 1. Only if everything is gone. We don't write 1A or 1B. We know there's a 1 there all the time. So we're not gonna write it unless everything divides out. I put it there right now just as a place mark. Okay, so let's go. You got a to the 4th, right, over a to the 7th. So the a to the 3rd is in the denominator, it stays in the denominator. You have b over b squared. There's 1 left over in the denominator, it stays in the denominator. Then we have c to the 8th over c. So you got c to the 7th in the numerator. And you can see, since c to the 7th is in the numerator, I don't need that negative 1, and I would not write it. It doesn't change the answer, it's okay. It's just that teachers are gonna assume you're not necessarily, on your game when they see you put a negative 1 in there. But like I said, it doesn't change the answer, but it's just something we don't do. All right, number 10. 10 over 5. Okay, both negatives. Remember your integer rules. When dividing, same sign, is always going to be positive, right? Now, p over p cubed. Subtract 1 from each. So the 1 in the numerator disappears, you're left with p squared in the denominator. It has to stay there. You have t to the 4th, right? Over t squared. Divide that out, and you have r over r. So it doesn't matter whether it's a number or not. Any value over itself, like r over r, that's 1. T squared over t squared, that's 1. So those literally divide out completely. And so your answer, well, it's just going to be 2t squared, right? And then the r's divide out completely. So that's your answer, 2t squared over p squared. So like I said, it doesn't matter if it's a variable or a number. If they divide out, they divide out. Okay, so what are we going to do now? We're going to add these polynomials. So we have 2 binomials. Now all this comes down to, when it says operations with polynomials, It's just a fancy way of saying combining like terms. And we learned combining like terms in Algebra 1, first semester, first week of first semester. So all operations with polynomials means in Algebra 2 is combine like terms. And you can see that we would add the g's together and the constants together. Now what I would do, as things get more complicated, I would move it right underneath it. I wouldn't just, I know you can do this in your head and look at it, move it underneath it, make sure you line up the proper terms, and that way you can't make any mistakes. So this ends up being what? 3g plus 12. And you can see I use the different colors so that you can easily see what lines up, what should be combined. But I know you already know this. So here we go. Here's something that you're supposed to know as an Algebra 2 student. No one's going to tell you. Your teacher's not going to say anything. It's not going to say on the test. Don't forget this. But anytime you see a negative in front of a set of parentheses, everything in that parentheses behind it, you must change the signs. You must change the signs before you combine like terms. Like I said, that's something you should know at this stage in your math career. No one's going to say anything unless you don't do it. They're going to mark it wrong. You're not going to get your points. So in the end, this becomes 4d plus 4. All right, 13. Trinomials, doesn't matter. Combine like terms. You see the x squared in the first set of parentheses? You have to find another x squared to be able to add it together. And obviously, you have 2x squared. So 2x squared plus x squared is 3x squared. Now, what I would tell you to do, like I said, take that second set that's in the parentheses, and I would move them right underneath, right where they go, and add everything up vertically. That way you don't make any mistakes. If we do it in our heads, which you certainly can do that, we have a tendency to make mistakes, even if it's something easy, especially if it's easy, really. So opposite signs becomes 4x, -3, -2, same signs add, keep the sign. And so our answer is 3x squared plus 4x minus 5. Number 14, okay? So, nothing special about that, right? It's not subtraction. We don't have to worry about changing the signs. All we got to do is combine like terms. So we have a -2f squared minus 3f minus 5, okay, in parentheses. Now the parentheses honestly have nothing to do with these operations. They just do this to show you that it was a trinomial, right? That's what was together. But it really has no basis on what we're doing. You could conceivably just remove the parentheses. So what are you going to add, right? Put them underneath it, add vertically, same signs, you add, keep the sign, it's -4f squared. You got another -3f, -3f, -3f. Keep the signs, got -6f. Now, I want to point out one thing. Notice you do not put like 6f squared. When we're adding and subtracting, nothing changes in terms of the variables as far as the exponents go. So there's your answer, 4f squared minus 6f plus 3. All right, now we're starting multiplication. So multiplication. Here's where variables and x can be multiplied by any other variable. Doesn't have to be like terms like we just did. So -5 outside of parentheses means to distribute. We have -10c squared, right? Plus 5d squared. Negative, same signs, always positive. Okay, so what do we end up with? We end up with -10c squared plus 5d squared. Okay, make sure that you multiply both terms in the parentheses. Okay, for some reason, some students have a tendency to only multiply to the first one. And there's your answer. So plus 5d squared. Now, we can't combine them, they're not like terms. We're done with this. Number 16. X squared times 2x. X squared times 9. Basic stuff. I know you know how to do this. So x squared times 2x, x squared times 9. What do you get? You get 2x to the third power, right? plus 18x. I'm sorry, that's stupid. Plus a 9x squared. All right, 17. Now, you know what's funny about this problem is I have the same thing happens every year. Students do not know what to do with this problem. They see a minus 5 in parentheses squared, and they're not sure what to do. But all that means is you have a minus 5 twice. You're going to multiply them together. That's what that means. Just think about it. If it was 2 squared, what would you do? You'd multiply 2 times 2. Here we have to multiply a minus 5 times a minus 5. Now, another mistake students make on this is they're going to go a times a, which is a squared, and 5 times 5, which is 25. And they'll think they're going to be done. But that's not, you're not distributing both every term in the first parenthesis to the second parenthesis when you do that. So here's the vertical method. I think it's the easiest way. It's what you're used to from 3rd grade. This is how you multiply. So we go 5 times 5 straight up, and we go negative 5 times a. When we go to the second term, we're going to move over one space, just like we did in middle school, where they had you keep that place value by putting a 0 there. But don't put a 0 there, because you're algebra 2 students. Just skip a space. All right, so then we're going to add vertically, we have a squared, right? Minus 10a plus 25. Look at the difference. I know that many of you would have put a squared plus 25, missing that middle term because you're not distributing to every value. Doing it the vertical method, you're going to make sure you do. All right, same thing here. 2x minus 3, 3x minus 5. We're going to put it underneath it. The vertical method. Negative 5 times negative 3, right? Negative 5 times 2x. We're going to write those values down. Make sure you keep your signs with you so you don't make mistakes. Negative 10x. We're going to move over 1 to the left, so we're going to write our first term under the 10x. We have negative 9x, and then we have 6x squared. We're going to add vertically. 6x squared. What is negative 10, positive 9, right? And then 15, and there's nothing to add to the 15, so there's your answer. 6x squared minus 19x plus 15. So if there's other methods for doing this multiplication, there's the box method, there's FOIL. And it doesn't matter what method you choose, but make sure you choose the one that keeps you organized and that make sure that you multiply every term in one parentheses by the second. All right, here we go, 19. So r minus 2t and r plus 2t. Now the reason why I'm doing this, although it's kind of redundant, is because you're going to have to know down the line that this is what we call a difference of 2 squares. You're going to see when we multiply this out, there's not going to be any middle term. They're going to subtract from one another. So this will end up being a difference of 2 squares. And that's what they're trying to get you to see. You see the two expressions, exact same, 1 plus 1 minus. The middle terms will subtract out, and you're going to be left with a difference of 2 squares. So the key is being able to work backwards to this. So if you got r squared minus 4t squared, you should know, right, that it's r minus 2t, r plus 2t. That's the key. We want you to be able to work backwards on this. This is a special type of function. See how the middle term is not there? All right, number 20. And this is the last one we're going to do because they're all the same from here. I mean, there's really nothing more to tell you. So, what method are you going to use? Some people like the box. It's okay, the box method, but I think wait till you get more challenging problems to use that. That's a lot of work and I don't think it's necessary in these problems, right? Or you can use FOIL if you're good with FOIL. A lot of kids aren't good with FOIL because they can't remember the steps. I'm telling you, I like this method for you guys. Negative 3 times 4, negative 3 times 3y, boom. 2y times 4, right? And then 2y times 3y. And vertically, you've already got everything lined up and you're good to go. So 6y squared minus y. You can put 1y, but like I said, we always know there's a 1 there. We don't need to write it. But if it helps you kind of keep everything in order, hey, I got no problem with it. Okay, minus y minus 12. That's all we have today for you, boys and girls. Remember, math, math, math. Get up and do some math.